Hello, welcome to Chemistry Travels. So today let's learn to draw the several oxoacids of sulfur from their chemical formulas and also learn to write their chemical names. So before we move on to the structures, there are certain key points that we need to understand. The first point is that all the oxoacids of sulfur that we're going to draw today are dibasic. So what does this mean? It means that the structure has two protonable hydrogens, which means that there are two hydrogen atoms in the structure that can be easily removed off as H+. And this is possible when we have an OH unit where from the OH, one of the H can go out as H+. So it simply means that all the oxoacids of sulfur has two OH units. The second point to remember is their oxidation states. So this oxoacids of sulfur exhibit four different oxidation states, out of which two are lower oxidation state and two are higher oxidation state. So what are the lower oxidation state and what are the higher oxidation state? The lower ones are +3 and +4. While the higher ones are +5 and +6, all near 1. 3, 4, 5, 6 are the different oxidation states, out of which 3 and 4 are lower, 5 and 6 are higher. And the chemical name of those oxoacids that have an oxidation state +3 or +4, that is the ones with lower oxidation state, their chemical name ends with the word OUS. OUS. That is like sulfurous, hyposulfurous, pyrosulfurous and all. At the same time, the oxoacids having higher oxidation states, that is the ones with sulfur in +5 or +6 oxidation state, their chemical name ends with the term IC, like sulfuric acid, hyposulfuric, pyrosulfuric and all. Another point to be remembered is the starting ones, that is +3 and +4 structures having +3 or +5 oxidation state for sulfur. Their chemical name has the starting term hypo. They will be like, if it's +3 it will be hyposulfurous acid, if it's +5 it will be hyposulfuric acid. Okay. Now based on the points discussed, we are going to draw 10 different oxoacids of sulfur. And for making them simple, we are going to group them into different classes based on their similarities in structure. Okay, so the first set out of 10, the first set is H2SO3, then we have H2SO4, and finally we have H2SO5. Similar ones, SO3, SO4 and H2SO5. So these are the three different, first set of three different oxoacids. So how do we draw the first one? So one key point is all of them will have sulfur. For example, the central atom will be sulfur. In this sulfur, in this sulfur, and for in this also, the central atom is sulfur. Now we told that all the oxoacids are dibasic, which means that they have two OH units. So let's put those OH units. So one OH unit for this and one OH unit for this, right? Now what extra we have to see? Two hydrogens, one hydrogen. That's done. One sulfur, that is also done from the formula. And now out of three oxygen atoms, two of them are already done. So the third oxygen atom would come out as a double bonded oxygen. Now sulfur has a lone pair of electrons also, right? So now this is the structure of H2SO3. Moving on to the structure of H2SO4, central atom is sulfur. Since it's dibasic, there will be two OH units, 1 and 2. Now, two hydrogens are done, one sulfur is done from the formula, and out of the four oxygen atoms in the formula, two of them are done. So where will the other two go? One of it will be double bonded like this, and the other one will be double bonded like this, replacing this lone pair. This is the structure of H2SO4. Now in a very similar fashion, let's draw the structure of H2SO5. So sulfur, again that is dibasic. So one OH here, and let's put one OH here. Okay, and then what is there remaining? 2 hydrogens are done, 1 sulfur is done, 2 oxygens are done. There are 3 more. So third one will come here, fourth one will come here. Now where will I put the 5th oxygen? And it is not possible to put the 5th oxygen somewhere attached directly to sulfur. So what is it that we can do? We can bring in the concept of OO bond, peroxo bond. So one of the OH will change to OOH like this, and OO bond is being formed. So this will be a peroxo compound. Okay. So these are the different structures of oxoacids of sulfur. Now let's look into their oxidation state of sulfurs to name them. So if you look into their oxidation state, we can see that this particular one is in +4 oxidation state, because this is like -2, -1, -1. So totally it's like -4, and sulfur will be +4. Here if you see, it's like -2, -2, -1, -1. So it's in plus oxidation state, +6 oxidation state. Similarly, here also if you check, you will see that this sulfur is in +6 oxidation state. So all of them are in +4, +6 and +6 oxidation states. And +4 is a lower oxidation state, so it will be OUS. So this one is sulfurous. OUS. This is sulfurous acid. And now +6 is a higher oxidation state, so it will be ic. This is sulfuric. And sometimes we can also call it as oil of vitriol. That's sulfuric acid. Okay. And last we have this peroxo compound. So it is a peroxo monosulfuric acid. This is also similar to sulfuric acid with an extra OO peroxo bond. So this is peroxo monosulfuric acid, and it's termed commonly as Caro's acid. The commonly called Caro's acid is peroxo monosulfuric acid, H2SO5. So we drew 3 from the 10 and the remaining 7 are written here. Now if you look into these, they follow the pattern like an extra oxygen is being added every time. H2S2O2, H2S2O3, H2S2O4, H2S2O5, then there's O6, O7, O8, extra oxygen gets added up. And to draw these structures, we can group them into 4 different groups. Like the first 2 that we have, H2S2O2 and O3 are one group. Then the O4, O5, O6, this is another group. Then O7 is another group. And O8 is another group. Okay. Now, why did I group them like that? It is because of their similarity in structure. The first set, S2O2 and O3, they have an S double bond S in their structure. Okay. Then this O4, O5, O6, they have a S single bond S in their structure. Then this H2S2O7, it has a SOS bond in its structure. And finally, this H2S2O8 has a SOOS, this bond in the structure. So now let's draw the structure for the first set, that is H2S2O2 and H2S2O3. Let's see how their structure comes. Okay, so as you can see, this 2 sets have S double bond S. So let's put that S double bond S. Now here also there will be S double bond S. Okay, both of them. Now what else can I say? We saw that all oxoacids are dibasic, so which means that the sulfur will have two OH groups attached to it, one OH, one OH. Okay. Now look at the formula and check it with the structure. 2 hydrogens, that's done. 2 sulfurs, that's done. 2 oxygen, that's done. So this is H2S2O2 structure. Coming to S2O3, there's S double bond S because it comes under this class. S double bond S is that. Now dibasic, so 2 hydrogens. 1 OH here, 1 OH here. Okay. Now what is remaining? 2 hydrogens are done, 2 sulfurs are done. 2 out of 3 oxygens are done. So the third oxygen would be attached to the sulfur as double bonded oxygen. Okay. This is the structure of H2S2O3, and now to name them, let's look into their oxidation state. So this sulfur at the top is similar to an oxygen being added, so it's in the oxygen family. So the sulfur will be -2. With this attached, the central sulfur will be in +4 oxidation state. Let's check -1, -1, -2. So totally -4 around it. Central one will be +4. So this is +4 oxidation state, and this one, if you see, -1, -1, -2 for oxygen and -2 for the other sulfur. So the central sulfur will be +6 and the other sulfur, the attached sulfur, will be -2. Okay. Now central ones, +4 and +6 we have. And also the ones with this S double bond S in their structure, they have the name thio in the start. Okay. The ones with S double bond S in the structure starts with thio, and this is lower oxidation state +4. So this is OUS. So this one is named as thiosulfurous acid. While this one also has S double bond S, so this is also a thio one with higher oxidation state. Central sulfur is in +6 oxidation, so this is thiosulfuric. Clear. Moving on to the next class, that is H2S2O4. Then H2S2O5 and H2S2O6. Let's draw the structures. So here what is the speciality? All of them in their structure will have a S double bond S. There's a S double bond S. This also has an S double bond S. This also will have an S double bond S. Now all of them are dibasic. All these structures are dibasic. Now, unlike the previous one where I put all the substituents on a single sulfur, here we are going to distribute them on both sulfurs equally in such a way that both of them will get a OH unit. So totally there are 2 OH units for the structure. One of it will go to this sulfur and the other one would go to the other sulfur. Okay. Now what is that? H2 done, S2 done. Now out of 4, 2 oxygens are done. Now there are 2 more oxygen. Equally distribute them between the 2 sulfurs. So 1 this sulfur would get, 1 this sulfur would get. Now all 4 oxygens are also satisfied. So this is the structure of H2S2O4. Coming to the structure of H2S2O5. Similarly, this is also dibasic. So let's go for OH and OH. Right, that is done. Then what is there? Oxygens. So double bonded O, double bonded O. Is it satisfied? Like 2 hydrogens are satisfied. 2 sulfur is done. 1, 2, 3, 4. So 4 oxygens are done out of 5. So where will the 5th oxygen go? And for the 5th oxygen, we can put it as double bonded O to any one of the sulfur atoms. Clear? Now the last one is H2S2O6. Similarly, now there is an S single bond S. Now dibasic, so there is an OH and there is an OH. That's done. Then what else is there? 6 oxygens are there in total. 2 are done, so 4 more are there. So it's like 1, 2, 3, 4. We're just equally distributing them. So now to write their chemical names, let's look into their oxidation states. So in this particular sulfur is in +3 oxidation state because it's like -2, -1. So +3. Similarly, this sulfur also is in +3 oxidation state. And this one, if you look, you will see that this sulfur is in +3 oxidation state. This sulfur is in +5 oxidation state. And for this one, -2, -2, -1, like all of them are in +5 oxidation state. This sulfur as well as this sulfur, both of them are in +5 oxidation state. Now, we saw that if the structure has sulfur either in +3 oxidation state or in +5 oxidation state, we told that they have the name hypo. Their name starts with the word hypo. So this one has +3 hypo, it is. And it is lower oxidation state, so it is sulfurous. This is hyposulfurous acid. This one, though it has 3 and 5, but it's a mix of 2. It's not just a 3 or just 5, so we can't put hypo there. This is pyro, and it is pyrosulfurous acid. And the last one is +5. So again, it is hypo. It is hypo and it's in the higher oxidation state, so it's hyposulfuric acid. Okay. Also, there's another name for this first and the last one, that SS, the first one and the last one. We can also call them as dithionous. This is like dithionous acid and dithionic acid, this last one. Dithionous and dithionic, that is hyposulfurous and hyposulfuric. Clear? Let's move on to the last two sets, that was H2S2O7 and H2S2O8. So H2S2O7. How do we draw them? We saw that it has a SOS linkage. So let's put down that linkage first. There is SOS. Okay. Now this is also dibasic compound. So one OH would come here for this sulfur and the other OH would come for this sulfur. Right. What else is there remaining? 2 hydrogens are done, 2 sulfurs are done, 1, 2, 3. 3 out of 7 oxygens are done. So we have 4 more. So 1 oxygen, 2nd oxygen, 3rd oxygen and 4th oxygen. So all the 7 oxygens are also satisfied. And if you look into the oxidation state, you can see that this particular sulfur, both the sulfurs are in +6 oxidation state. So since they are in +6 oxidation state, they are higher oxidation state. So this one is termed as pyrosulfuric acid. Okay. And commonly you can call them as oleum. Clear? Moving on to the final oxoacid for today, that is H2S2O8. This one has a SOOS linkage in its structure. So let's draw the structure. SOOS. Now what else we have to put? Dibasic. So there's one OH here and another OH here. What else is there? Now 2 hydrogens are done, 2 sulfurs are done, 1, 2, 3, 4. 4 oxygens out of 8 are done. So we have to put the remaining oxygens. The sulfur will get 1, 2. Similarly, the sulfur also gets 1, 2. Here also we can see that these sulfurs are in +6 oxidation state. Okay, so higher oxidation state. So this is also sulfuric and it has a peroxo unit, OO linkage. So this is peroxo disulfuric acid. Similar to the one we saw initially in the first class, we saw peroxo monosulfuric acid, which is Carrow's acid. This is peroxo disulfuric acid, and this is Marshall's acid. Common name, peroxo disulfuric acid. So that's it for today, and I hope this video will help you learn and remember the structures of several oxoacids of sulfur in a much easier fashion.